Welcome to emstatonline. Random numbers in numerical Python. What is random number? Random number does not mean a different number every time. Random means something that cannot be predicted logically. Pseudo-random and true random. Computer work on programs, and programs are definitely set of instructions. So it means there must be some algorithm to generate a random number as well. If there is a program to generate random number, it can be predicted that it is not truly random. Random numbers generated through a generation algorithms are called pseudo-random. Generate random number. Numerical Python offers the random module to work with random numbers. Example, generate a random integer from 0 to 100 from random is equal to random dot random integer 100 prints. In this case, any random integer we can print. Suppose we need to generate a plot from 0 to 1. Same we can write example from numerical Python import random x equal to random dot rand index. So in this case, output is 0.3214123, just like this. Suppose we want to generate a random array. From numerical Python import random. You generate one D array containing 5 random numbers. So random dot ran integer 100 comma size 3 is equal to 3. Print x. Suppose we need random number 2D array with some rows. In that case, random dot num integer 100 comma size equal to 3 comma 5. Print x. In plot case, So y is equal to random dot rnf5 print y. Plus 2d array z equal to random dot rnd 3 comma 5 print z. Return one of the values in array, then w is equal to random choice 3 5 7 9 print w. We want y parameter, then some d is equal to random choice 3 5 7 9 size equal to 3 comma 5 print b. The output of each case, first one, the random integer 100 size 3. So in this case the output is 25 54 72. That's all, any 3 random numbers. The next one, 2D array with 3 rows and each containing 5. So in this case 45 35 25 10 11, 5 numbers, 3 rows. So 25 21 9 10 10 45 85 90 78, just like this. So third one, float. So in this case random of 5. So this case here 0.8987234, 0.32456, 0.9878, 0.999. Now random of 3 comma 5, that means each row containing 3 random, this one 0.1425, 0.1124, 0.3256, 0.246, 0.38. So 3 rows 0.125, 0.326, 0.781, 0.981, 0.86, 0.86. So another one 0.691, 0.75, 0.92, 0.57, 0.62. If generate random number array, return one values in the array. So choice, we can give any number with choice. So in this case let us assume 7. In random choice 3 5 7 9, 3 and 5 size. So this case output is 9 3 5 5 7 3 5 7 7 9 3 3 5 9 7. Data distribution. Data distribution is a list of all possible values and how often each value occurs. Such lists are important when working with the statistics and data science. The random model offers a method that returns randomly generated data distribution. Random distribution is a set of random numbers to follow a certain probability density function. Probability density function is that describe a continuous probability, that is probability of all values in an array. We can generate a random numbers based on defined probability using the choice method and random model. The choice method allows to specify the probability of each value. The probability is a set of numbers between 0 to 1, where 0 means that values will never occur and 1 means the value will always occur. Example, generate a 1T array containing 100 values, where each value has 2, 3, 5, 7 or 9. The probability for the value of 3 is set 0.1. Similarly, we can set the probability value. Example from numerical Python import random x equal to random choice three 5 7 9. The corresponding values 0.1 0.3 0.60, size equal to 100, 20x. So in this case, the output five 5 5 7 3 6 7 8 9. Okay, 5 7 6 8, not 8 6 5 5 9 5 5 5 5 7 5 5 5 9 9 9 3 3 9 9 3 3 3 3 3 5 5 3 3 3 7 7 9 9 9 9 9 3 3 5 9 9 9 3. Randomly generate the sum of all probability numbers would be 1. Even if you run the example above 100 times, the value 9 will never occur. Random permutation. The numerical Python random module provides two methods for this shuffle and permutation. Shuffle means changing the arrangements of elements in place in the array itself. Example from numerical Python: import random import numerical Python as np. So array equal to np.array 1 2 3 4 5. So random dot shuffle dot array print array. So in this case it shuffle the elements inside that array only. The output is just like this: 5 1 4 3 2. The shuffle method makes change to the original array. Permutation, same case, we can write print random dot permutation. Permutation method returns the rearranged array and leaves the original values unchanged. The output is 5 4 2 1 3. The distributions. Normal distribution. The normal distribution is one of the most important distributions. It is also called Gaussian distributions, after the German mathematicians Carl Friedrich Gauss. It's fit the probability distribution of many events. Use random, not normal, method to get the normal data distributions. It has three parameters: LOC, that is mean, where the peak of bell exists; scale, standard deviation, how flat the graph should be. The third one is size. Size means the shape of the return array. Example: generate a random normal distribution of size 2 cross 3. That is from numerical Python, import random, x equal to random dot normal, size equal to 2 cross 3. print X. The output minus 0.001, 0.3308, 0.799 is closed. Then minus 0.012, minus 0.321, minus 1.3160. Suppose get the random normal distribution of size 2 cross 3 with mean 1 and standard deviation 2. So in this case, from numerical Python, import random x equal to random dot normal mean equal to 1 and standard deviation is equal to 2, size equal to 1 cross 3, 1 comma 2, print X. So in this case, one 1.4, 4.2, 0.6. Comma 2, so that's enough. We can visualize the normal distribution. The curve of normal distribution, also known as the bell curve, because the bell-shaped curve. Binomial distribution. Binomial distribution is discrete distribution. It describes the outcome of binary scenario. Toss a coin, it will either be head or tail. It has 3 parameters: numbers, that is n, p, probability of occurs of each trial, and size, the shape of the return array. Discrete distribution. The distribution is defined at a separate set of events. A coin toss result is discrete as it can only head or tail, whereas height of people is continuous. It can be 160, 175, 162, and so on. Example, give 5 trials of coin toss, generate 10 data points. So from numerical Python, import a random x equal to random dot binomial, n is equal to 10 trials. So probability of coin toss probability is 0.5 and the size equal to 3. Print X. So in this case, the output is just like 1, 2, 2. Because output is only 3. Next, Poisson distribution. Poisson distributions is a discrete distributions. It estimates how many times an event can happen in a specified time. It has two parameters. I, AM, rate or known number of occurrences, 2 for above problem, and the size. Size the shape of returned array. From numerical Python import random x equal to random dot Poisson equal to 2, size equal to 3, print x. The output is 3, 2, 2. Uniform distribution. Used to describe probability where every event has equal chance of occurring. Generate of random numbers. Here three parameters. A is lower bound, B is upper bound, this 0, this B is upper bound 1, size, shape of the return array. So in this case, from numerical Python import random, x equal to random dot uniform size equal to 2, 1, print x. That means the output is 0.341, 0.730. This. And the next distribution is logistic distribution. The logistic distribution is used to describe growth. Used extensively is machine learning in logistic regression, neural network, etc. It has three parameters. OC, that is mean. Scale is a standard deviation, the flatness of distribution, default to 1. Then the third parameter, size, shape of the return. So example, draw 2 cross 3 sample from logistic distribution with mean at 1 and standard deviation 2. So from numerical Python import random x equal to random dot logistic mean 1, standard deviation 2, size 2, 3, print x. So in this case, the output is just like this, size is 3. So 0.42, 1.2 minus 0.87 and 2.35 minus 3.5 minus 0.46. The next distribution, multinomial distribution. Multinomial distribution is a generalization of binomial distribution. It describes the outcome of multinomial scenario, unlike binomial, where scenario must be only one of two. Here, the three parameters: n is the number of possible outcomes, p as list of probability of outcomes, and size. It's the shape of the return array. Multinomial samples will not produce a single value. They will produce only value of each p-value. As they are generalization of binomial distribution, their visual representation and similarity of normal distribution is same as the multinomial, multibinomial distributions. Example, draw out a sample of dice roll from numerical Python, import random, x equal to random multinomial, n is equal to 6, p-value is equal to 1 by 6, 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 print x. So it's a random multinomial case. So the output is just like 0, 1, 2, 1, 2, 0. Next one, exponential distribution. Exponential distribution is used for describing time till next event, success or non success. The two parameters, scale and size. The scale is inverse rate, default 1. So example, from numerical Python, import random, x equal to random dot exponential scale is equal to 2, size equal to 1, print x. So 2 rows and 1 column, that is 0 0.2, 0 0.1. That's all. Then chi-square distribution. Chi-square distribution used to basis to verify the hypothesis. It has two parameters. One is df, degrees of freedom, and size. Example, draw out a sample of chi-square distribution with a degree freedom 2 with a size 2 cross 3. So from numerical Python, import random, x equal to random dot chi-square, degrees of freedom equal to 2, and size Okay, 2 cross 1, print X. So 2 rows, 1 column, 6.38, 2.94. Suppose 2 cross 2, then 2 cross 2 matrix, just like this. The next distribution is relay distribution. Relay distribution used in signal processing. It has two parameters. One is scale, standard deviation, and size, shape of the return parameter. So this one example from numerical Python to import a random x equal to random dot array distribution, that is scale equal to 2, size equal to 2 cross 1, print X. Similarly, two rows and 1 column, 3.3, 1.2. The next distribution, Pareto distribution. A distribution following Pareto laws, 80 to 20 distributions, 20% of factors cause 80% of outcome. It has two parameters. One is shape parameter and size. So in this case, example from numerical Python, import a random x equal to random dot Pareto a equal to 2, comma size equal to 2 cross 1. Print X. It's a random Pareto distribution. 2 cross 1, 2.56 and 0.53. Then another distribution, zip distribution. Zip distributions are used to sample data based on zip law. Zip law, in a collection of nth common term, is 1 by n times of the most common term. It has two parameters. One is A, distribution parameter, another one is size. Example from numerical Python, import random x equal to random dot zip a equal to 2, size equal to 2 cross 2. Print X. The outcomes 2 cross 2, so okay, 26, 1, 3, 1.